Alright, so in 4.5 we start solving exponential equations and logarithmic equations. The best way to solve some of these is just to use rule 1. If you start out with the exponential, you write it as a logarithm. If you start out with a logarithm, you write it as an exponential. But there are some other techniques that we're going to use here. Let's look at this first example. So a to the x equals a to the y. Then you know that x has to equal y. If the bases are the same, the exponents must be equal. So if you got 5 to the x equals 125, you can write 125 as 5 cubed, so x has to equal 3. 5 to the 2x equals 5 to the x plus 1. Well, that means their exponents must be equal, and when you subtract x from both sides, you get x equals 1. Now here's one technique for solving it. You isolate the exponential on one side of the equation, take the log of both sides, or you can use rule 1, and then use the laws of logs to bring the exponent out of the exponential and down front. Then you can solve for the variable at that point. So here's an example. 3 to the x plus 2 equals 7. If you take the log of both sides, you get log of 3 to the x plus 2 equals log of 7. You can bring that x plus 2 out front. Alright. Now if you divide both sides by log 3, and you can do that, you get x plus 2 all by itself, and then just subtract 2. And now this is your exact answer, and this is your approximate answer. Example 3 here. 8e to the 2x equals 20. You want to isolate the exponential, so divide by 8. And now you can take the log of both sides. Now if you do log base e, it'll be nicer. Let me show you how. You take ln of both sides. ln of e to the 2x is just the exponential, 2x. And ln of 2.5 is whatever it is. And now if you just multiply both sides by 1/2, that gets rid of the 2. And this is your exact answer, and that's your approximate answer. Same idea here. You got e to a power equals 4, so you can take log base e of both sides. Log base e of e to the exponent is just the exponent. And now you subtract 3. And then if you multiply by -1, that makes that positive 2x. And when you multiply these by -1, the ln becomes negative and the 3 becomes positive, so you can write it this way instead. When you multiply by -1, the left changes sign and the right flips the order. From ln of 4 minus 3, it becomes 3 minus ln of 4. And now you just multiply everything by 1/2 to get rid of the 2, and you end up with this. This is your exact answer, and that's your approximate answer. Now if you want to solve the same problem using your calculator, you graph y1 equals the left side, y2 equals the right, and you got to be able to see your intersection point. Typically if you hit zoom 0, it'll show you, it typically will show you the intersection point. At that point, hit second trace 5 and hit enter 3 times, and you'll get an answer. And remember, you only care about what the x value is. The x coordinate gives you your answer to that question. This one is a bit tricky. E to the 2x minus e to the x minus 6 equals 0. This is a quadratic function. It doesn't look like it, but it is. If you look at the middle term, that'll tell you what is your number that's being squared, and then the number itself, and then the constant. So you can write e to the 2x as e to the x times e to the x. You can write 6 as 3 and 2. And now you got minus 3 e to the x and plus 2 e to the 3x gives you minus 1 e to the x. And now you set each one of those equal to 0. And you solve, you get e to the x equals 3 or e to the x equals -2. So if you want to solve that, take the natural log of both sides, ln of both sides, and you get x equals ln of 3, which is this. Here, if you take the log of ln of both sides, you get ln of e to the x equals ln of -2, but you cannot take the log of a negative number. So that part does not give you a solution. Only this part does. Now the other way you can do this is you can say, alright, this is my x, this is my x squared, so let w equal this guy. And then this guy ends up being w squared. This is w, and there's your constant, and you can solve it just like you would if it was x. You set each one equal to 0, and you get 3 and negative 2. But now you have to back substitute and replace w with what you let w equal. And then when you solve each one of these, you'll get your answer. Notice on this one you get an actual answer, and this one you get no real solution. It's the same question, I just solved it two different ways. Now example 6, if you factor out an x and an e to the x, you end up with 3 plus x inside the parentheses. And so you get x times e to the x times 3 plus x. So each one of those can be set to 0. And so one of them gives you x equals 0 as an answer. Another one gives you x equals negative 3 as an answer. And this one, when you take the log of natural log of both sides, you're trying to take the ln of 0, which you cannot do, and that's not possible. That does not give you an answer. The other two do. Now the other way to solve the way to solve logarithmic equations is to isolate the logarithm, and you might need to combine logs, and then use rule 1. Another way you can do it is what they do in rule 7 here. They set the logs equal to each other, and they take away the logs, and you get something you can work with. So log 5 of this equals log 5 of that plus log 5 of that. These two are being added, so you can write them as multiplication. So this becomes log 5 of x minus 2 times x plus 3, which is really going to give you that. Now if you got log 5 of this equals log 5 of that, then this has to equal that. You can take away the logs, and these two have to be equal. And now when you subtract x squared, and then you add 6, you get x equals 7. Number 8, ln of x equals 8, so that means e to the 8 equals x. And you get your answer, which is approximately that. And this one you can use rule 1 again. 2 to the 3 equals 25 minus x, so that's 8 equals 25 minus x. Subtract 25, multiply by negative 1, you get your answer. Notice, by the way, when you get these answers, you have to check them. You have to plug them into the original problem, and if at any time whatever number this is negative, your answer is not a real solution. But if you plug 17 in for x, you get 25 minus 17 is 8. 8 is positive, so that is an acceptable answer. Alright, so this one you want to isolate the logarithm by subtracting 4, dividing by 3, and then just use rule 1. 10 to the 4 equals 2x. Well, 10 to the 4 is 10,000. Divide by 2 and you get 5,000. And now you should check it. 2 times 5,000 is 10,000. That's positive, so that's okay. Example 10a. You get log plus log equals 1. Well, you can write the addition of these logs as multiplication. And so when you bring these together, you're multiplying x plus 2 times x minus 1, which gives you this. And now use rule 1. 10 to the 1 equals this. 10 to the 1 equals that. Well, 10 to the 1 is just 10, and when you subtract 10, you get minus 12 on the right. That factors down to these two. Set each one equal to 0, you get minus 4 and positive 3. Now if you plug 3 in here, you get 3 plus 2 is 5, that's positive. 3 minus 1 is 2, that's positive, so 3 works. Minus 4 plus 2 is negative 2, no. Minus 4 minus 1 is negative 5, no. Even if it only gives you a negative for one of them, you have to throw that answer out. Alright, now the other way to solve this is graphically. You can graph the left side, y1 equals the left and y2 equals the right, and then second trace 5. Enter, enter, enter where they intersect. You might have to hit zoom 0 first, because remember, to find an intersection point you have to be able to see the intersection on your screen. Okay, now this one, if you bring the x squared over here, it becomes subtract x squared. And now if you graph y equals this, you're just looking for the x-intercepts, places where this thing equals 0. So when you graph this, just do second trace 2, and that will help you to find the x-intercepts. And there happen to be 2 of them. Now you might say, well, wait a minute, that can't be an acceptable answer because that's a negative number. Well, check it. Negative 0.71 plus 2 is a positive 1.29. Positive. So even though you're plugging a negative number into here, when you add 2 to it, it becomes positive, and that's the number you want to be positive. And then 1.6 plus 2 is 3.6. That's positive as well. So both those are legitimate answers. Now this one is the compounded interest problem, and now they're asking you for time, t. How many years will it take for 5,000 to grow to 10,000 if it's compounded semi-annually at 5%? I think what they say is how long will it take for it to double. So if they start with 5,000, you know you're going to end with 10,000. So 10,000, 5,000, and all the other numbers here, you don't know t. Divide by 5,000 and you get 2 equals this guy. Okay. And now you take the natural log of both sides, you get this, and you can bring the 2t out front. Okay. And now if you divide by 2 and you divide by ln of 1.0125, you get t all by itself, because the 2 and the ln's go away, leaving you with just t. Well, that part gives you approximately 14.04, which is how many years it will take for the money to double. And then they ask you the same question for money to double if it's compounded continuously. So you're using this formula. You don't have an n anymore, and you're solving for t. So you get 10,000, 5,000 e to the 0.05 t. So you divide by 5,000, okay? And now you take the natural log of both sides, and when you take the natural log of e, you just get the exponent, and then divide by 0.05, and this guy gives you 13.86, which makes sense because if you're compounding continuously versus compounding semi-annually, you're going to get, it's going to grow faster. It's going to take less time for it to double. Example 13, they give you 5,000, or they give you 1,000 and ask you when will it grow to 5,000 at 4%, compounded continuously. So you plug in all those numbers and then you divide by 1,000. You get 5 equals that. And now you take the natural log of both sides, and because you got log base e of e to a power, your answer is just the power, the exponent. Divide by 0.04 and you get your answer, 40.24 years. Takes quite a while. Alright, so this one, now we're solving actual problems out of section 4.5. E to the x squared equals e to the 9, so the exponents are equal, and x has to be 3 or negative 3. 10 to the 2x minus 3 equals 1 over 10. Well, 1 over 10 is 10 to the negative 1. Remember, that's 1 over 10 to the positive 1, and when you cross the fraction bar with that, it becomes a negative 1. So now your exponents are equal and you can solve for x. Here, your exponents are equal. You subtract 2x, you subtract 6, divide by 3. Here your exponents are equal. You subtract 3x, you subtract 1, you divide by negative 5. Here you can take the natural log of both sides, or you can just write, use rule 1, log base e of 5 equals the exponent negative 2x. And then if you multiply both sides by negative 1/2, you get rid of the negative 2. And this is your exact answer, and that's your approximate answer. Then this one, you divide by 3 to get your exponential all by itself, and now you can use rule 1. Log base 6 of 5 equals the exponent 1 minus x. So you got this guy, and if you subtract 1, you get this guy equals negative x. And if you multiply everything by a negative 1, it becomes 1 minus that, because this becomes negative and that becomes positive. And now that's your exact answer, and that's your approximate answer.